In the circuit shown below, for the MOS transistor, mu n into COX equal to 100 mu ampere per volt square and the threshold voltage Vt equal to 1 volt. The voltage Vx at the source of the upper transistor is, the options given are A is 1 volt, B 2 volt, C 3 volt, D 3.67 volt. First of all, let us understand some small concepts on Mosfet. Okay, in an Mosfet, NMOS, in any Mosfet, there are three terminals. First one gate, source and drain. This is called VGS and this is called VDS. In a MOS, gate, drain and source. In this MOSFET, the current flows from drain to source. The current Ig is always 0. The gate current is always 0 in MOSFET. Whole drain current will go to source. Therefore, Id equal to Is. Now, first of all, when will current exist, that we should know. There are some conditions in MOSFET. First of all, VGS is the voltage. This is a very important voltage. VGS. This is called VGS, right? When VGS is less than some threshold voltage Vt, this should have VGS. This VGS should have minimum value. Otherwise, there exists no current. Whatever be the voltages, whatever be VDS, there will exist no current at all. This is called cutoff region. Okay. Now, if VGS is greater than Vt, means what? This voltage is greater than the threshold voltage. Therefore, current may pass. Then if current passes, how much current will pass? Okay, there are two regions here. First one, linear region. This region says, what is the current? Id is equal to W mu n COX by 12 into 2 times VGS minus VT into VDS minus VDS square. Okay, when does this occur? When VDS is less than VGS minus VT. When VGS is greater than VT, then what happens? The current will flow from drain to source. But at the same time, VDS slowly increases. When VDS is less than VGS minus VT, then this is the linear region we said. Okay. Next, saturation region. Id equal to W mu n COX by 12 into VGS minus VT whole square. Here, VDS is greater than or equal to VGS minus VT for the saturation region. Saturation region also occurs when VGS is greater than VT, but this condition also. See, here VDS is less than VGS minus VT. When VDS increases, what happens? The whole current is increasing. But up to what limit? When VDS is less than VGS minus VT. When VDS keeps on increasing, then what happens? At some stage, VDS is greater than VGS minus VT. At that time, the current follows this equation. This is called saturation region, where all the current is constant. Okay. So in MOSFET, you should remember only these things. There are gate, source and drain. VGS less than VT is called cutoff. VGS greater than VT, there are two conditions, linear and saturation region, and the current equations are these both. Okay. Now we should solve for this circuit. Let us say this transistor be B, this transistor be A. Metal oxide field effect transistor. Okay. Therefore, MOSFET can also be called as transistor. This is gate, this is what? Source, and this is drain. For B MOSFET I am drawing. In the B MOSFET, if you look, it is like this. And this is combined with this one. Means what? Gate and drain are at same potential. And the source is grounded. Okay. Here you see, we want to first check VDS is how much? This is Vx, it is given. Look in the up circuit. VDS equal to Vx minus Vs. Vs is 0. And VGS is how much? G is connected to drain. Therefore, VG is also Vx minus 0. Okay. Therefore, now check. VDS is what? Greater than or equal to VGS minus VT. See here. VDS is how much? Vx is greater than or equal to Vx minus Vt is 1 given. Therefore, this is satisfied. This condition is satisfied, which means saturation condition is satisfied. The current should be this formula. Therefore, ID is how much? W mu n into COX by 2L. First of all, W by L is given as 1 for this one, and mu n into COX is given as 100 mu. Right? Therefore, W by L is how much? 1. 1 by 2. W by 2L is present. Mu n into COX is 100 mu. Right? Into VGS minus VT whole square. See here. VGS minus VT whole square. What is VGS? Vx. Vx minus Vt is how much? 1 square. This is the current through ID. Okay. This is the current passing through this point. Okay. Now, what is the current passing through this point? The same current. Means that this current is equal to this current. For the transistor A, let us check here. What is VGS? VGS equal to 5 minus VG is 5 minus Vs is Vx. This is gate and this is source for this transistor. And this is drain. And what is VDS? VDS is how much? 6 minus VD is 6 minus Vx. Okay. Now check this condition. VDS is how much? VDS greater than equal to VGS minus VT. If you check it, you will see that VDS is 6 minus Vx greater than equal to VGS is how much? 5 minus Vx minus 1. Therefore, 4 minus Vx. Therefore, this condition is satisfied. Therefore, this is also in saturation region. Transistor 1 is also saturation region. For the transistor 1, this is for transistor B. And for 1, ID is how much? W into W by 2L. Right? W by L is how much for this transistor? 4. Therefore, 4 by 2 into mu n into COX is how much? For both the transistor, it is given 100 mu ampere per volt square. 100 mu into VGS minus VT whole square. What is VGS? VGS is 5 minus Vx. 5 minus Vx minus Vt. Vt is 1 whole square. Right? Therefore, this is the current through the transistor A. Both these currents are equal. You understood why? Because the same current flows from A to B. Now equating those both. What do we have? This is 50 mu into Vx minus 1 whole square is 200 mu into 4 minus Vx whole square. Therefore, Vx minus 1 is how much? 2 times 4 minus Vx. Vx minus 1 equal to 8 minus 2Vx, which implies 3Vx equal to 9. Therefore, Vx equal to how much? 3 volt. Therefore, Vx is given as 3 volt. Okay. First of all, in any gate paper, the questions on MOSFET are always this type, and mostly it is given in saturation region only. First of all, for all these questions, just remember this result. There are gate, drain, source for MOSFET, and there are three regions. Check for saturation, linear or cutoff region, and solve by this method. Okay. Here, option C is correct. 3 volt is the answer.